Okay, let's get started. Hi, everyone, and for those that are coming in, welcome. Thank you for joining us today for a session on programmable business, building secure multi-agent AI systems. My name is Albert. I'm from Shakudo, and I'll be moderating today. Just some quick housekeeping. We're live and recording. You'll receive a full replay and shared resources after the event. If you have any questions, feel free to just drop them in the Q&A at any time. Feel free to upvote the ones that you want answered, and we'll try to cover most of the questions if we have time. So today we'll be covering the topic of AI agents and multi-AI agent systems. Today's session will be about real-world deployment of agents in an enterprise environment, specifically how to do it securely, fast, and in a way that scales. So we're here with we'll hear both the foundations and some live case studies of how this is done in practice. Joining me is two leaders in this space. Why don't you guys introduce yourselves?
Dave, do you want to go first?
I was going to ask you, but all right. I'm David Stevens. I'm the Vice President of Artificial Intelligence for Central Reach. We're a EHR, EMR platform that serves the needs of autism therapy providers, providing services to those living with autism or other intellectual developmental disabilities. And we've been recently rolling out generative AI applications across our customer base, as well as internally. And we're doing so with the help of Yevgeny and Shakudo, the Shakudo team. So I'm just going to talk a little bit about some of our experiences and how these applications and agentic workflows could be deployed across any enterprise.
Thanks, Dave, and I can go next. My name is Yevgeny. I'm one of the founders and the CEO at Shakudo. And Dave and I have been working together now probably close to a year and a half, approaching a year and a half, since we started talking. I think it was December 2023. And we've done a lot together, and we most recently started building agents, and that will be the focus of the discussion today.
Okay, thank you both for the introduction. So let's dive right in. Yevgeny, the floor is yours.
Yep, thanks, Albert. So I think we can talk a bit about agents overall, and we don't really need to anchor on the slides too much, but we can use them just to facilitate the conversation a bit. So I'll give my perspective on agents, and then would love to get Dave yours as well.
Yeah.
In short, I think there's really two primary things that work remarkably well in the world of current AI, and that's agents and code generation. And code generation can also be an agent. So really it's agents. Agents work very well and achieve business operational efficiency, productivity efficiencies, quality of life improvements, pretty much everything that we kind of hope for these agents to do. And we'll talk about how they work, why they seem to be effective. But I'll save some of that for later. Dave would be
Yeah,
great.
so just one of the things that you see, and we talk about this often, Yevgeny, is how Shaku's been through several hype cycles already in the world of technology since your founding. Starting out like in crypto, and everybody's like Web3, and all these other things that got a significant amount of hype and awareness, kind of fizzled out. They didn't really have real world applications. So there was a technology looking to for a problem to solve. And while there are use cases for those things, it's not as widespread as maybe everybody thought, a few years ago. But what I think is, and you could sort of see similar, so the hype cycle with AI agents. They're becoming the noise of 2025. Everybody's talking about AI agents. And to that extent, it feels like a little bit of a hype. However, I think this time is real and this time is different. And the reason, and it's not just sort of me and some of the people that are doing these tools and seeing the capabilities of them, but it's some very large companies that are now publishing and going public with the amount of impact that, or the magnitude of the impact that AI agents are having on their businesses. Yesterday we saw McKinsey post some more information, or just earlier, maybe last week, more information about their internal knowledge agent called Lily, and some of the impacts that's having across their company, including on the quality of life side of things. Bank of America most recently published some of their findings or success that they're having, their ROI with agents at an extreme scale, 2 billion interactions now with these AI tools, and then Fujitsu. And this body of evidence of showing like there is actual real proof. People, companies, large companies and small, but the large companies of the world are demonstrating their significant ROI on the application of AI agents in their businesses and out to their customer base. So I'm going to argue heavily that this is not a hype cycle. This is real. And to me, it feels a little bit of like a tsunami kind of coming, where most of the knowledge work that we do in business is going to get transformed through the use of agents.
So Dave, I agree. And I think really a lot of the kind of the questions that emerge recently is why, what specifically makes agents work? And so there's a few different ways to think about it. The most exciting way is, of course, agents are really kind of just a step towards general artificial intelligence. That's how true AI eventually will work, and that may be true. The more kind of dry and practical way to look at agents is they're really loops, right? So we all know LLMs, we all use ChatGPT, or maybe Anthropic, and we all kind of went through this process of completing a task by asking ChatGPT a question, uploading a document, and then asking follow-up questions until we get to the answer that we need. Agents do a very similar type of work with two important differences. The follow-up questions are constructed by LLMs as well. So you have the LLM that potentially pulls knowledge from its kind of training data and responds to questions, but you also have the LLM that decides what to do next and what to ask next. But more importantly, the agents can use tools. So they can make calls to APIs. They can use local tools, remote tools. For those who are following the space, there's a standard that's emerging called Model Context Protocol, which was originally introduced by Anthropic, but now adopted by OpenAI, Google, and Salesforce, and others. And that's a standard way of defining tools, so that no matter how you've built the tool, as long as it's conformant with the MCP protocol, any agent framework that supports it will be able to make use of these tools. And so you end up with these loops that continuously try to take actions, observe the results, and then follow up. And that's ultimately how people work as well in many cases. So we have quite a few examples of it working effectively, and we'll go through some of these today in more detail. But just at Shikudo, there's at least three different types of agents that we use internally. We have our go-to-market engineering team, which has created extensive amounts of agents that automate pretty much everything that we can in sales, except for the actual human interaction. So all of the prospecting, lead scoring, team metrics, reports, reminders, everything is fully automated. And not all of it is agentic, but almost everything is either done through a full agent or a workflow that uses AI agents. I'll talk about other use cases as well, but Dave, I think what's most interesting really, Shakudo is a tech company that builds an operating system for data and AI teams. So our agent use cases are also built for AI. I think what's most interesting to folks in the audience probably is what types of agents does a company like CentralReach build, and more broadly, what are you seeing in the ecosystem? You're involved with a lot of startups. What are some of the successful agents that you see out there?
Yeah, so that's a great question. And I actually want to just back up one step. Like that is a very good analogy or explanation of agents, around how what an agent loop is in AI sense. And it's actually probably the best I've heard it explained, to be honest. So that's a good one. I might steal that one, Yevgeny. But essentially, it's like getting the AI to essentially try something, evaluate whether it did it right, and then continue in a loop to make sure that it meets the expectations or the quality or the acceptance criteria that you give it, and that you can give it tools to then go call, especially with the new advent of the MCP standard. It makes it much easier to wire a bunch of different disparate systems together. In fact, recently I just saw it referred to A2A, which is an agent-to-agent framework or pattern that Google, I think, released. And with now the tool calling pattern of MCP, it's almost like a hidden sort of operating system across the entire internet. So anybody that exposes their services or capability through the agent to agent or the MCP pattern can have their unique offering and capabilities orchestrated by tools like what we're going to see today. So I like that analogy or description. So in terms of where we're using it, I'm not going to get into specifics. We consider a lot of the stuff that we're doing with you kind of proprietary, but it's very much along the lines of what we see here. One, we're using it to help answer people's questions about a very deep and broad domain of data. And one of the challenges our customers face is just the deluge of data that they have to reason about. And traditionally with BI tools or just other user interfaces, you leave a lot of the hunting for information and sort of collecting that information up to the users themselves. So they'll have to go to different places across the application to pull the specific information they need. Might be in different formats depending on the user that put it in. Sometimes there can be problems with, or not problems, but just challenges of getting everybody to standardize on the same sort of terminologies and things like that in our system. And so using AI as a knowledge retrieval engine is showing significant promise, and especially as we approach it with an AI agent perspective. So you can ask natural language sort of client oracle type questions or questions against a client, in this case, a patient oracle, saying, hey, when was the last time X might have happened? What were some of the precursors that might have been present in the data? And again, that used to be a very laborious thing that you'd have to spend a lot of time with a human going through the records to find these types of things, because you have to translate the semantic question you have in your mind into the queries that the system supports. But the agents, they can take that semantic, that natural language question you might have, understand semantically what it means, call the relevant tools, which we'll see an example of here with the knowledge graph use case, and then compile a report for that particular user. So I think just knowledge management, knowledge retrieval, I think is probably the biggest use case of an AI agent workflow. The second would be like we have with the BDR agent, compiling reports. I do a lot of work with the Llama Index team and Jerry and Bizawoop and Simon over there. And one of their biggest, their main focus is on creating and generating derivative reports and information out of these knowledge retrieval systems. And again, they're also approaching this from an agent workflow. So Llama Index workflows, Llama Index tools, LangChain, there's a bunch of different libraries out there. In fact, there's a multitude of libraries out there, but they're all trying to solve the same thing. And it's digest, collate information, and then create derivative reports or actionable insights from that information without having a human kind of do that laborious project, work over and over again. And then on the kind of the last one where I'm seeing is like you want to start taking action based on the analytics or the reports that come from our data. And that action might be, for instance, if you've ever dealt with, a support bot from like Intercom now, right, where you can talk to and they have Finn where you can say, hey, I'm having trouble with XYZ. Yesterday, I was trying to transfer an account I have in a platform that was using something. I'm not sure what agent they were, but I was like, hey, I want to transfer this account to another person. I don't want to do the expense report anymore for that. And what popped up in the chat was like, great, what's your ID? What's the ID of the person? And it gave me user interface on demand. And it basically took care of the transfer of that account. So taking action to me is the next step of agents. And if you've collected and you've connected the agents to the tooling through MCP or otherwise, they can now use their reasoning loops to figure out what to do to solve a customer problem. So I think those are just, I would imagine, Yevgeny, you can almost put every one of the agentic use cases into one of those three buckets. Maybe there's a couple more, but we're either going to take action on behalf of somebody through a semantic reasoning loop. We're going to use our semantic reasoning to find and share knowledge with you, or we're going to use it to kind of summarize progress over time on whatever business case that you're managing, right? So from a standard operating procedure compliance perspective, or just a general reporting and recommendation system on what to do next to move various KPIs.
Yep. No, I completely agree, Dave. And I guess maybe one kind of follow-up question for you. One type of use cases, which I do think probably fits into one of these buckets, but I'm curious and where you would put it, that we're seeing on the rise now is RPA agents, right? So robotic process automation agents that use a browser and use a computer vision model or sometimes analyze the web page itself to perform actions. And the big difference between RPA agents that are AI based and kind of the old generation is that the AI based RPA agents don't need to be programmed too strictly. You can just give them instructions, go to a page, find the button, click the button, type in a specific text box. Whereas in the past, you had to actually record the steps, and if something changed in the page, then your RPA would stop working. So we're seeing that quite a bit now with this.
I think if you looked historically on like our RPA, and I think UiPath just came out with something along these lines, but traditionally RPA has been a very challenging thing to do, especially if you're trying to orchestrate websites or other tools that you don't control. You're essentially at the mercy, at the whims of the changes to that system that affect the operational aspects of the RPA tool, the bots itself. And so having AI that can iterate and use not just vision models, but you can still use the traditional tools like Puppeteer and so forth. You can even do them in combination, but it becomes much more robust to changes in the system. And it's much easier to sort of quote unquote program those RPA tools to go take action. So I do think it is still in the orchestrator agent category, but I think maybe that just goes to the fact that we probably need to do a better job of defining what tools can be wrapped with MCP, like browser use, for instance. I just saw MongoDB release this morning that they added an MCP server to MongoDB Atlas, right? So now you can actually talk to your Mongo collections directly through these tools, which basically enables your LLMs to talk to them. So it's a very, very interesting what we're going to be orchestrating here over the next 6 months.
Yes, and actually, to your point about MCP and being attached to development tools, one very interesting combination that we've both seen and are using ourselves at Shikudo is taking AI coding assistants. Like we're all familiar with Klein, Aider, Goose, the
Cursor, Windsurf, all of them. Copilot.
Correct. I always mention the ones that run on-prem or on Shikudo, but yes, as well. When you connect MCP tools to these AI assistants, what's interesting is your code assistant can now understand your destination systems, so the systems that the code interacts with, and actually write better code, or code that's more tightly coupled with your data schemas, with your access constraints, with kind of the remote APIs. So a typical flow for our engineering team would be to write an application that connects to either a data lake or a data warehouse. And as part of the development process, they would use the MCP servers for Mongo, for Postgres, for Dremio inside their Visual Studio Code sessions on Shakudo to say something along the lines of, hey, I need to retrieve the list of contacts from my CRM table. Go and check the schema and write the Python code to connect to that database and retrieve the data, right? And that would be along the lines of the types of prompts that go in. This is materially different from programming with a chat bot like ChatGPT, where you have to copy paste database schemas. You have to do a lot of that work yourself. So totally agree on that. By the way, I'm getting a bit of background noise. It's gone now. All right, so let's keep going. So we talked a bit about why AI agents. Let's talk about multi-agent systems. So this one, I actually think I have a somewhat controversial perspective on, but so maybe for that reason, I would love to get your thoughts first, Dave, before I make any controversial statements about multi-agents. What are your thoughts?
So I think that's where the real value is going to be had in the deployment of agents, is that you can generally get one agent to do very good, be very robust and capable at a very specific sort of finite task, right? The more sort of you make it do, the less it's maybe going to do at all of those things. And so what we're seeing is a little bit of a cap on the number of tools you would make available to any particular agent flow, right? So if you give the LLMs too much to think about, they can get lost. That'll probably get better over time, no doubt. But what we see as the best practice today is try to limit the scope of the agent as sort of tightly as possible, right? And so where the agent to agent agents calling other agents and orchestrating other agents comes in, is that you basically are passing, like if you think about a kitchen in a restaurant, you have the waiter and the wait staff and the you have the chef and the sous chefs and the meal preps and all that stuff, the dishwashers. You have a bunch of different people that have specialized, and you can think about agents as the same as in the same concept. So you want them to specialize, and then you want to orchestrate them together to solve a problem. And this is where that orchestration layer comes in. And what I was pretty excited to see from some of our earlier demos, Yevgeny, with the Shakudo agent flow, is that as you build these sort of specific purpose-built general but purpose-built agents, they can be orchestrated like having a bunch of people on the bench to pull in for any particular job. So I do see that as the future of agents. So highly specialized, capable agents that you orchestrate to solve novel problems as the demand arises.
Yeah. So
was that controversial? I don't know. Is that, or are you going to tell me I'm wrong?
I think your perspective is kind of the mainstream perspective on this. I would say my controversial perspective on this is there's not at this point. So I agree with you that as the agent ecosystem evolves, that's the end state, or at least the short-term end state. So within the next few months or maybe a year. But right now, we're not seeing a lot of benefit to the multi-agent systems compared to agents that use tools. And let me make an important distinction. Some of these tools can be agents themselves. So in Agentflow, which is the application you mentioned, every agent that you create and deploy actually becomes an MCP tool, as well as an A2A compatible agent. But the agent itself can be used both in a multi-agent system as one of the participating agents, and as a completely stateless tool that other agents can invoke. And so what we're seeing is that the stateful multi-agent interactions are not that much better at this point than a single stateful agent. So only one agent that kind of keeps track of where we.
Yeah, so I totally understand that, and I would totally agree with you. We have not solved the state problem between agents, and I think there are platforms out there like the Mem0s, and there's a couple other ones that are kind of trying to solve this thing. But it really becomes like a RAG or a context management problem that we have to solve, right? All you need to do is provide the right context to the other agent so it can kind of continue where it is.
Right.
And I think what you're referring to is that mechanism is still being figured out best practice. We're still trying to figure out how to provide the right context to the agent or to the LLMs at the right time. And so, yeah, I would agree with you there. That's
exactly right. So the simplest version of it would be a single orchestrating agent that passes all the relevant context to every tool and agent every time it invokes them. And that's probably inefficient.
Yeah.
To your point, but it currently seems to be the most performant approach compared to multi-agents where each agent maintains a state, which is, I think, should be the end goal. And really the end goal should also include the agents having shared state, right? So part of the state is kind of their own and part is shared, that they all
I mean, that's the whole job of computer programmers is state management. So it doesn't seem like that's going to change with the AI agents.
Right. It's just a different way of doing it.
Yeah.
Maybe one more thought on this, and then we can move on to the next stage here, and maybe even get into the demo soon. But one thing I've observed over the past year is a lot of folks who were not previously familiar with AI terminology are adopting it very quickly. So you hear fine-tuning mentioned a lot. You hear reinforcement learning mentioned a lot. It's usually not used in the same way that it's used by AI academics, which sometimes can create some misunderstandings. But what I'm very interested in is agent self-improvement, call it. Reinforcement learning is what I've heard people refer to, but it's not the reinforcement learning in the traditional kind of reinforcement learning ML sense. It's really how can the agent continuously improve just by doing its thing, right? So just by either being invoked through external signals or events, or by running on a schedule, how can agents can be continuously better at what they're supposed to do? And also, what is better, right? So one aspect of agents which everyone is kind of dealing with right now is if an agent runs again, so you run it twice on the same input, if there's no state across the two runs, then it will go through the same process with some variations due to randomness, but it will go through the same process of kind of rediscovering the parts of the world that it doesn't know.
Yeah.
Right? For example,
it's a goldfish, right? Just forgets that it just did the same thing and does it again, right?
Yeah, essentially, right? So the easiest example would be all the agents that interact with data warehouses or data lakes, or even I'm sure the Mongo MCP server can be used the same way. You ask it a question, find me a table of invoices. It will go list all the schemas, list all the tables, look at everything that sounds like an invoice table, check the schema, sample some data, and then come back with a result. And then if you ask it the same question again, it will repeat that whole process again, but with maybe in a slightly different order. And so that is incredibly inefficient when you roll out agents in production.
Well, it's not only inefficient, it's very error prone, right? Because you just said like there's a randomness to the outputs of the LLM. They are stochastic systems, so they're non-deterministic. And while you might be able to run it, 100 times, 95 of the times that you ran it, it comes out the same, but there's 5% of the times it's not going to. And so what I like about what you're saying is that if it ran through and it did it correctly, why introduce that randomness to the second time it runs? Why not just cache the sort of execution plan and the code that it writes that it knows is good. And it says, oh, I just solved this problem. I'll just run it again. I don't have to go think my way through it. Right. Yeah.
Exactly.
100%.
Yes. And so that is a very interesting area of both research and a lot of builders are working on it as well. And I think that's really critical for agents in real operational settings.
Yeah, otherwise you can't really trust it, right? Like, because it's going to have randomness in its output, and the longer your LLM chain and the more loops of your chain of your LLMs, the more chance of randomness and errors getting in there and then propagating down through to the end result.
Yeah. So exactly, there's the errors issue where you don't know, will it discover the world correctly or not this time around.
Yeah.
But there's also the issue of the cost multiplier. Assuming you're using a model provider like OpenAI or Anthropic, every run takes up some tokens. And
my developers love to show me their client where it's like, hey, this costs you $1.37. It's like, okay, great.
yeah, exactly. So that if you have that thousands of times, and
it adds up.
Yeah, it adds up, and more importantly, if it can be avoided, it should be avoided, right?
Most of our focus right now is having the AI help us build tools that are now something you run. It's not another inference that runs. It's the tool gets created as an artifact of an output of an LLM or an agentic workflow. And then we're able to run that and tune it like you would in a normal SDLC process.
Yeah.
Software development lifecycle. Sorry.
Yeah.
Use acronyms.
Agreed. All right. So let's get into a demo. Before we get into a demo, let's just briefly talk about security and the way we approach it at Shakudo. So security of AI agents is critical. If you go on X or on LinkedIn and look for posts on the topic, you'll find a lot of memes. And that's because the state of security in early agent implementation was pretty scary. A lot of hard-coded credentials, a lot of credentials being sent in open channels. But that obviously for very clear reasons, with agents being used by enterprise and increasingly kind of taking a life of their own in terms of solving business problems that actually matter. Security is being addressed very rapidly, which is great to see. On Shakudo specifically, credential management for agents is done through the same standard vaults as credential management for every application. So that would be, Shakudo is cloud agnostic, can be deployed on Azure, GCP, AWS, or on-prem. And each of these cloud providers has their own credential vault, which can be used as the backend for credentials that used by agents if the agents are deployed on Shakudo. Same with on-prem deployments. On-prem systems have different ways of protecting credentials, but those same vault mechanisms can be used as well.
Yeah, like for instance, we're using Azure AD for some things. We use our own internal SSO for some other things, and it's been very robust against supporting against those different authorization and authentication systems.
Yeah, actually, that's a great point, which we should cover. There's authorization and authentication, as you said. So before even talking about credentials, just how do agents get access to anything? And so you're right, agents should operate as service accounts or as service users that have permissions, groups, just like a regular user. Yep. And that can be managed through Azure AD or Okta or any standard identity access management system. All right, so let's talk a bit about Agentflow. So Agentflow is an application that runs on Shakudo. So let me pull up my environment here. Just bear with me.
Am I going to see something new today, Evgeny? Every time you show a demo, I see new stuff. So.
I can't remember if when we showed it to you last, if we had the agent memory in it or not.
No, I don't think I saw the agent memory.
All right, so you'll see something new today. All right, so this is my Shikudo demo environment. For those of you who are not familiar, Shikudo is a Kubernetes-based operating system for data and AI that runs on the customer's infrastructure. So it gets deployed right next to the customer's data, so the data can stay where it is in the ownership and control of the customer, while Shikudo operates the best-in-class tools and products in the data and AI space inside your VPC or on-prem. So that kind of brings together the two worlds of high value, high compliance, high security data with the world of very innovative, very effective products that are being built by the ecosystem. And we won't do a full demo of Shikudo today. You can always reach out to us through our website or through LinkedIn. Happy to set up a demo. We'll just focus on one application here, which is called Agentflow. So Agentflow is a tool built by Shikudo, and it's built for a very specific purpose. Everything that Shikudo builds is designed to make the best technologies on the market in that category easy to operationalize and easy to use. And Agentflow is no different. So in this case, we're going to look at an RPA agent. So everything is managed through Git. All the agent definitions, all the code that's created are all deployed into a Git repository and checkpointed at every step.
And for the non-developers on the call, it's the same thing that all your developers are doing, and they're managing their source code and the instructions in a Git repository, so you can do version control, rollbacks, and all of those SDL, software development lifecycle things.
That's correct. Thanks, Dave. And so we'll look at a couple of agents and how to create them in Shikudo and in Agentflow. So a few elements here to point out. We'll get to the main canvas here in a moment. You'll see this list of tools on the sidebar here, 95 tools available. Those tools come from two sources. One is a list of MCP servers. We mentioned those earlier. So these are standardized agent tools, which can exist anywhere inside Shikudo, outside of Shikudo, and you can register them here in the MCP server tab, which we may get to later. The other source for tools for Agentflow is other microservices that you have running on Shikudo. So that can be any kind of microservice. It can be an API endpoint, can be fast API, can be developed in Python, JavaScript, Rust, whatever is your standard tool for creating microservices. Once you deploy a microservice on a cluster that's operated by Shikudo inside your infrastructure, you will get it auto-discovered here in the sidebar, and your agents can start using that tool if you add it to the canvas. This is very important because many organizations already have a large ecosystem of microservices. Right? Microservice architecture is not new. It's very pervasive across the industry, across enterprise. And so the goal here is to allow every organization to leverage existing systems by agents. Of course, carefully controlled in terms of access and usage, but not require any re-implementation. That's just on the tools discovery. And now let's look at how we create agents on the canvas here. So this is a very simple agent, which can be quite powerful, and we intentionally picked it as the first one to look at because it can really do anything that a browser can do. It has one tool, which is a browser tool, and if we click on edit here, we can see the prompt, so the actual kind of instructions to the agent. And it's really pretty straightforward, right? So we could tell it to use the browser tool to browse the web, analyze web pages, and interact with them.
I think one thing I'd like to add here is that if you're not really familiar with the prompts and you've really only used ChatGPT sort of for like maybe trivial question answering, the AI LLMs are getting very, very good at instruction following and through this thing called prompt engineering. And so what you're reading here is the actual code, in language format that you're sending to the LLM to instruct it to go do something. So it's natural language. It's arguably the same level of instructions and details you would give to a junior associate on your team, right? A very eager junior member of your team and say, hey, go do these things. These are the quality standards they want. These are the steps you need to take. Same thing here with these prompts as we're sending these to the LLMs. You write in natural language. A lot of times you just start with your internal documentation or SOPs, and you port them a little bit to get better output. But essentially, it's just give it the instructions. And that's what you see here. This is you now programming RPA.
Exactly. So this is, thanks Dave for that additional context. It's exactly like Dave said, it's almost like a project definition or a task definition for a person. You'll describe to the agent who they're supposed to be, what their task is, and any additional nuances about using the tools they have available. Right? So we gave it some information about how the browser tool responds and interacts. And then we gave it a couple of important pointers. You don't need to try to interact with the web yourself. I'll explain why this is important. The browser tool will handle it. And then we also mentioned to the earlier discussion, we also mentioned that the browser tool is stateless. So if you're going to use it multiple times, you have to give it all the information that's needed. It doesn't remember between invocations. All right, so one other interesting, maybe not so important for this demo, but interesting thing to point out is this is a code agent. So the agent itself is actually going to write code, generate code to complete its task, and then execute it on the fly every time. And this is underneath it's using the Hugging Face small agents framework. But Agentflow supports other standard frameworks like LangGraph, LangChain, of course, AutoGen, CrewAI, and other standard frameworks that are broadly used. We generally like the small agents framework because it has a very small code base and because of the code generation approach that it takes.
So this code generation, this goes back to our earlier conversation of that. Once it runs this process based on your instruction, it'll save the code needed to do that again. So if you wanted to replay it, it could just run the code that it generated versus having to reason about and maybe come up with the same answer.
Exactly. That's and if the code is stored in a way that can be retrieved effectively, then you encounter a version of the code that works, it can be retrieved next time and used in future runs. All right. So let's very quickly look at a more complex agent in the canvas here, and then we'll kind of see it in action, the agent itself. So this was a very simple agent. Another more complex agent that we use heavily internally, and usually it's overloaded by our team actually, is this one. We call it Shackbot v3. It has a lot of nicknames. The internal nickname for it is Shakudo Baby AGI. We tried to change it to something that sounds more serious, but the team liked it and it stuck. So that's what we end up using. This is the main agent that the Shakudo team uses internally, and it has access to all of the internal knowledge within Shakudo. It contains information from across the business, emails, phone call transcripts, video call transcripts with customers and prospects, internal messages on various topics, PagerDuty incidents, GitHub issues, everything that the team does that has anything to do with our business or with our product is somewhere in one of the knowledge graphs that are accessible to this agent. And it's used very heavily by new hires. So that's the fastest way to learn how things work in the company, what a particular customer needs or what a particular product feature does. It's also used by our go-to-market teams to respond to customer questionnaires. I'm sure those of you who are in the B2B space are familiar with vendor questionnaires, RFPs. Instead of going through a lengthy internal project to create a working pot of people pulled from different teams and create a response to a questionnaire, you can actually just run it through this agent, and it will leverage everything that the company knows to complete the questionnaire as effectively as possible. This is a heavily used agent, and you can see it has quite a few tools. Look at the instructions here. It's pretty simple. We basically just tell it which tool to use for what purpose. Web Researcher is used for online research. GraphRag is used for internal knowledge base when it comes to business-related topics. And then the Dev GraphRag, by the name, should be clear, is actually the knowledge base of the engineering team. It also takes a while for this to process because it does quite a few follow-ups. And this is where agents become much more powerful compared to one-shot retrieval systems like RAGs and GraphRags. In a typical RAG, for those of you who haven't heard the term RAG, is retrieval augmented generation. So it's essentially using LLMs to perform semantic search, typically on enterprise data. The limitation there is if you don't get the correct response, you still have to follow up manually. You might get an incomplete response. You still need to do additional searches, additional research. An agent can do that automatically quite well. And so this agent, the Shackbot v3 that we're looking at, generally goes and relentlessly follows up with the various knowledge bases until it created the most comprehensive response that you can get within the company at this moment. And so it takes it a while to run. It can take 5 to 10 minutes sometimes. All right, so let's look at a few other aspects of agent flow. But Dave, any comments? I guess you're...
Well, no, this one's interesting because it's like exactly the McKinsey Lilly knowledge graph, knowledge agent that they probably spent, tens of millions, if not more, building. And here it is kind of out of the box that almost business users can set up if given the proper tools. So this to me is the democratization of knowledge management within organizations, assuming you have the privileges and the sort of the access, the authorization to the data you need. You now can use this tool to create and orchestrate any type of information retrieval across any disparate data set you might have based on your unique access needs and roles. So I can see a future where every knowledge worker essentially has a version of this with their own custom instructions on what they want them to go do for them in terms of knowledge retrieval. So just
yeah, I do think that agents are the right way to do knowledge retrieval. It saves
100%.
Yeah, it saves a lot.
Yeah, how many people find the thing they want after the first thing? Right, the first, even if you're looking in Office 365 on OneDrive, or if you're looking in Google or whatever, how many times are you searching? And like you're trying to remember, what did I call that thing? Or what was a word in there that I was looking for? Versus having agents, you describe an outcome you want and let it go figure out how to do that, what to search for, and get you the answer.
Yep, absolutely. All right, let's take a look at a couple of other aspects of agent flow. So previously we were looking at the canvas with the agents can get designed. The next step in the agent lifecycle is to actually create the code for this agent. And this toggle here that is mystically or mysteriously named Neo4j step history is actually the knowledge graph that represents agent memory. You have the option to turn it on or off. I'll explain what it means. But if we click on the generate code button, we're going to see an entire implementation of the agent, which is designed to be a standalone microservice. So all the Python files and kind of the scripts in here are created using best practices around deploying agents as a microservice. This implementation is committed to the Git repository. You can see here Git sync successful. So it's ready to go, right? We designed the prompts, we connected tools. Now this package is fully independent, fully standalone, can be deployed as a microservice on Shikudo or elsewhere. It's really a standalone Python-based microservice. And so I turned the Neo4j step history off here, but if I turned it on, there would be additional code elements here which memorize successful execution paths. So runs of the agents that are actually completed. And
so you're going from a goldfish to an elephant back to goldfish, just flopping that switch.
Yeah, it's exactly. It's it's elephant is a I guess a good analogy here. I think the most important thing to keep in mind about it is the memory, kind of storing the runs is one thing, but then retrieving them effectively so that you only pull the most relevant previous runs to the current run is another challenge, which can be an entire topic of conversation.
Well, yeah, that's where scoring rubrics and performance rubrics on the output of these things becomes very important.
Agreed.
Yeah.
And so once the code is generated, I could actually take this out of Agentflow right now. If I wanted to, I could go into Visual Studio Code and keep developing the code or run it on my laptop. But Agentflow does give you the tooling to keep going. So the next step in the agent development lifecycle is typically to test it as a local service within the Agentflow Manager app. I already have it running here, the RPA agent we talked about earlier. So there's a local microservice that's up and running, and I can kind of see its logs here. I know it's already doing quite a bit of processing. I think it might be almost done, if not done yet. Yeah, so I think it's currently running, but I can also skip the testing phase. So this is really just to kind of send some prompts to the agent and see if it works, if it does what it's supposed to do, and see the logs the way you would see them when you actually deploy it standalone. But once I'm done testing, I can go to the deploy tab and click on deploy to production. This does several things. It's a one-click deploy that creates a microservice with this agent. That microservice becomes a standalone agent that can be invoked through an API call, can be used as an MCP server on its own, and used as a tool within other agents. And it's actually automatically discovered here on this list. So if all these tools that start with agent dash, those are actually previously designed and deployed agents in the Agentflow Manager. One last feature I'll show you here, and then maybe we can have a quick chat and wrap up, is the telemetry data. So as the agents run, they record their steps either in Neo4j or in another data store. And that gets visualized here in the Agentflow Manager. So you can see the list of previous runs. There's a few interesting things here, or at least I think they're interesting. So first, you can actually see the chain of thought of the agent. You can see the steps it took, and you kind of how until it eventually converged. The colors and the weight of these blocks represent how much time and how many LLM tokens were consumed in the process. And this is for those who are technical on the on the webinar here, this is very similar to the profilers of code, right? So you can kind of see where is the agent spending the most money, where is it spending the most time, and then go and observe, is there anything we can extract from that step that it can skip next time? If it's just trying to figure something out, we can just build it back into the prompt, or if we're using agent memory, then we can actually expect it to remember it after a few iterations and not have to repeat the same mistakes. The other interesting thing here is these feedback buttons. So those go back into the agent memory as well. As you're developing the agent and run it on various inputs, you can then go into the jobs tab and say, hey, this was a really great execution. Like, you figured it out. The output was what I wanted. Just try to do more of these. And that is a very simple mechanism that feeds back into the knowledge graph.
So it's real quick. That's the perfect example of reinforcement learning at a system level versus an LLM, the weights level, right? Like the actual values in the LLM that were reinforced this way. And you're now saying this system of this entire system gets that reinforcement learning feedback on subsequent executions to help it get better every time. It's like coaching your kid learn how to throw a fastball in baseball or whatever. You're constantly giving guided feedback and reinforcement when they're doing it right, and that's that same feature here at a agentic system level, which is just fascinating. It's so neat.
It's really fascinating, and what I like the most about it is it works really well.
So this is where your SMEs are in here, right? It's not a coder or a developer. It's an SME who understands what good is and is going through and seeing this chain of thought, inspecting the input of or the output of one step to the input of the next, and saying, "Oh no, this isn't correct. You're making the wrong. You're doing the wrong thing here." Giving that feedback to the agent or the system and having it self-correct on subsequent ones. So it's so important to get the business users into these tools, even though they're a little technical, because they're able to quickly judge whether or not it's working well, and then give that feedback to the system, just as if they were working with an intern or a junior associate.
Yep, completely agreed, Dave. And there's a lot more to show, but I know we're kind of coming up here at the end of the hour, so
I could talk about this all day long.
How are we doing on time? Are we out of time, basically? Or?
Yes, yeah. We are just about running out of time. So yes, we can wrap up here. I'll just give a few seconds for there's any questions that are rolling in. In the meantime, I can. There were some questions that we collected beforehand, so if you want to answer some of these, you can go. Let's see here. So one of the questions was, do you see agent systems replacing traditional pipelines? What's the boundary? When should you agent systems? When should you not? Yeah.
That's a good question. What I'm going to infer to that question is like the typical RPA process where you're trying to do business process automation through various, mechanistic means where you're like literally plotting out the sort of the work path for these tools. I think with the advent of O1, which is OpenAI's reasoning model, these systems are showing very, very good capabilities around figuring out how to solve problems through with the tools given. And that can reduce a lot of the upfront work that you would typically have to do with humans kind of moving these boxes around. So I think absolutely that the whole business process automation is essentially will move to this method, especially if the humans have the ability to go in and sort of tune it as it goes and monitor it over time, right? And then that feedback gets back into the next round or next iteration of instances.
Agreed. And what I'm most fascinated by is how when that state management, this kind of continuous state management that we discussed earlier, becomes good. Like I think right now it's kind of weak, but as it becomes good. What can those agents do? If there's multiple agents constantly coordinating and constantly remembering things that worked that didn't work for them, is that a system that's just automatically improving all the time? That would be really fascinating to see.
I think that it's soon, like it's 3-6 months in my mind, right? It's happening so fast.
Great.
Good question.
Yeah, for
Go
sure.
ahead.
Let's see. We just have 2 more quick questions here. In terms of business operations and business functions, which kind of functions do you guys have seen the best use case for agent systems, and what?
I think definitely on the retrieval side, right? This is a retrieval of information is a hard thing to do across many different disparate systems that are generally pretty difficult to connect, right? So traditional means to connect them all involved massive projects around creating a lake house and all these different departments having to feed data to this lake house, and then only like the people that know how to query the lake house can use it. And I see these agentic research agents, if you will, being able to democratize access to those corporate data sets. So, and then 2, the other reason why that one's so good is that the person asking the question, as long as you've developed the system enough to give it the citations of where that data came, are their own judge of whether or not the AI was correct, right? So you're not actually relying on or betting on the fact that the AI is going to be correct. It's by nature a human in the loop process because you're asking it a question. You're hopefully not going to take it for face value. You're going to do a little bit of your own research to verify that it's correct and it's in it what it retrieved. But you're going to use that as a next step. So from a getting started perspective, these sort of agentic research knowledge type applications are a great place to start because 1, it solves an immediate need. There's immediate efficiencies gained by giving your staff more access to more information as they need it. And then 3, it's already human in the loop. You're not going to have like downstream dependent things on it that if it goes wrong, there's a lot of error correction and quality control that you have to do. So I'd argue that one's a very good one. The other one that might be good too is just the reporting. And we didn't get into that one as much on your BDR one, but essentially it's the same thing as the knowledge agent where you're taking a question, you're applying it to a body of information through various tool calling. And then you're just doing one extra step and saying, summarize this all for me in a report, right? So the first one was, here's all your information. The next one is just summarize this into this report and give me maybe some action items I might want to take. That's another one where the human's in the loop. Like now you could go and say, hey, the AI said, Albert, you're doing a really poor job on your lead qualifications, and Evgeny can kind of maybe dock you pay or something. Mm-hmm. And he doesn't go and actually QA it. Well, that's on him, right? That's his fault if it's not true. But again, there's human in the loop there. And those are very good places to start where it's a product that a human is going to go use, because then you have somebody that can judge the quality and go in and tune the system, which is why it's important, I think, to get your SMEs and business into these types of tools.
Mm-hmm. So I'll add just very quickly, I think the retrieval is absolutely strong. We have had some good results with automation as well, both in DevOps automation and go-to-market automation, where the agent uses one of our in-house built microservices to take an action. It could be cleaning up the cluster. It could be sending a message to one of our sales reps to let them know of a very promising lead. But generally, Shecudo as a system is also evolving in the direction of increasing the breadth of coverage of its DevOps automation capabilities through agents. So fundamentally, Shecudo contains quite a bit of DevOps automation, given that it's a product that operates other open source tools for you. And agents allow us to build those much faster. Sometimes an automation that would previously take 2 weeks to implement can now be done in half an hour. It will work less perfectly than before, right? It's less perfect than a fully coded automation. But if it's either that or manual, the agent is definitely a better option and a more cost-effective one.
And you can put guardrails around that too, right? Yeah. Like you can have it give you the plan of what it's going to do before it does it, and like there's all kinds of techniques to limit the impacts of an AI that got it wrong.
Yeah.
What was the next question, Albert? I think that was the last one.
Yeah, that was the last one. I think there was another one based on more about the Shakudo platform. I think it's they were saying we've already deployed kind of some open source tools. Can Shakudo orchestrate across them, or is this a full kind of re-platform sort of idea?
No, that's a great question, and the short answer is yes. The more nuanced answer is let's talk and find out. Right? It depends on how you've deployed the collection of open source tools, but our goal is to make that world that you've created for yourselves easy to operate. That's the goal. So so we should definitely chat.